Hello, my name is Gabe. For this problem, we're given the equation of an ellipse, and we're asked to find the center, the foci, and the vertices, and then we're asked to sketch the graph of the ellipse. So, looking at this equation, we see that it isn't in standard form. So our first goal should be to write the equation of the ellipse in standard form. So in order to start working towards the standard form, let's group these x terms together and the y terms together. So what we'll have is we'll have 25 times x squared plus 50x. Now I'm going to place a parentheses around these two terms. Then we'll have a plus 4y squared. Now the last thing I'm going to do here, working from the top line to the second line, is I'm going to add 75 to both sides of the equation so that this is equal to 75. So now what we're going to want to do is we're going to want to complete the square here. So we have this 25x squared plus 50x. We want to complete the square. So our first step should actually be to factor out a 25. So factoring out a 25, what we're left with is 25 times the quantity x squared plus 2x. Now I'm going to leave a little bit of space here so that we can come back and complete the square. And we'll have a plus 4y squared. And this is still equal to 75. Now, we'll want to complete the square in here. So looking, we see that b is equal to 2. If we take half of 2, we have 1. Squaring 1, we have 1. So we'll add 1 inside these parentheses. Now, we'll want to be careful because we didn't really just add 1 to this side of the equation. We added 1 times 25, so we really added 25 to the left side of the equation. So we'll want to add 25 to the right side of the equation also. So what we're left with is 25. Here we know that this factors into x plus 1, quantity squared. We're adding 4y squared. And this is equal to 100. So we're getting closer to our standard form. So I would say let's make the next step dividing everything by 100 so that we have a 1 on the right-hand side of the equation. So we're left with a 25 times quantity x plus 1 squared divided by 100 plus 4y squared divided by 100 is equal to 1. So our next step should be to simplify each of these terms. So the first term, this will simplify to an x plus 1 quantity squared divided by 4. This term will simplify to a y squared divided by 25, and this is equal to 1. So at this stage, we have the standard form of our ellipse, and we can pick up a few key pieces of information here. So just looking at this, we'll see that our a squared value is 25. So what that tells us is that a is equal to 5. Our b squared value is equal to 4. So that tells me that b is equal to 2. And now we can find our c value. So recall that c squared is equal to a squared minus b squared. So in this case, we're going to have our c squared is equal to 25 minus 4. So c is equal to the square root of 21. So now that we have these couple pieces of information, we can go ahead and write down our center, our foci, and our vertices. So our center is going to be given by -1, 0, and this comes just from observing the standard form of the ellipse. So here, our h value is -1, thinking about this x plus 1 as x minus a -1. And our k value is going to be 0. Now, to find the foci, well, here is where we'll want to look at our c value. So a couple things to note here. Our ellipse is going to be vertical, so the major axis is going to be vertical. So if we look at the foci, or the focus points, well, we'll want to start from the center. So the x-coordinate of our center is -1, but our y values of our focus points are going to be the 0 plus c and 0 minus c. So we'll have 0 plus the square root of 21, which is just the square root of 21. And we'll have the same x-coordinate, -1, and we'll be subtracting the square root of 21. And now we want to go ahead and we want to find the vertices. So remember, this major axis is vertical. So we'll think about starting at the center. The x-coordinate for both our vertices will be -1. And we'll want to think about moving up a. So in this case, we'll be moving up 5. So here we have our 0 plus a in the y-coordinate. And our second y-coordinate is going to be -1, the same x-coordinate. And then the other y-coordinate is going to be 0 minus a. So in this case, -5. So now what we can do is we can actually use this idea of the center and our two vertices to sketch the graph of our ellipse. So we said the center was at -1, 0, which is this point here. So our ellipse is not going to pass through that point, but that sort of guides us as to what our ellipse is going to look like. We have our two vertices as -1, 5. And our second vertex is -1, -5. So with just these two vertices, it would be really hard to sketch the graph of our ellipse. So what we'd want to do is maybe let's try to find 2 more points on the ellipse. So what we'll do is we'll find the endpoints of the minor axis. So that's pretty easy to do. We know that the x-coordinates are going to start with -1, and what we're going to do is we're going to add and subtract b. So we'll have -1 minus 2 is going to be -3, and we'll have the same y-coordinate as our center. And to find the other endpoint, we'll start at -1, and we'll add 2, and we'll have the same y-coordinate. So here we have 1, 0. So let's go ahead and let's plot these 2 points. So -3, 0, and 1, 0. So just to reiterate, these 2 points are not technically vertices, they're just the endpoints of our minor axis. These 2 points are vertices because they're endpoints of our major axis. Now, to sketch the ellipse, we'll just connect these 4 points. And there we have the graph of our ellipse. Thank you.